Alright guys, we're going to take some notes today over Unit 2 where we're going to talk about the structure of the atom. And this first part we're going to be looking more at where the idea, the theory of the atom really came from. And people way back in ancient Greece were thinking about atoms. Most ancient scholars thought that matter was composed of earth, water, air, and fire. But there were some that actually got into what an atom is. And if we take a look at two of the early Greeks, Democritus and Aristotle, they both kind of had contradicting views. So Democritus was really the first person to propose the idea that matter was not infinitely divisible, meaning there was the smallest thing, and he called those small particles atoms. Aristotle disagreed. He thought that you could break everything down further and further because there was no such thing as empty space. All right, so that kind of summarizes the difference between Democritus and Aristotle. Now, if we fast forward to the 1800s, we get to a guy named John Dalton, and he was really the first person to come up with a true atomic theory that was based on experiment that had some ideas about what matter is and what it's made up of. And there are 6 parts to his theory. Dalton said that matter is composed of extremely small particles called atoms. He thought that atoms are indivisible and indestructible. So Dalton thought that atoms were the smallest thing. He didn't know that there was anything smaller than an atom, which for the 1800s, that's pretty good. He said that atoms of a given element are identical in size, mass, and chemical properties, which we're going to disprove later on in the notes. He said that atoms of a specific element are different from those of another element, which is true. Different atoms combine in simple whole number ratios to form compounds, which is true. And in a chemical reaction, atoms are separated, combined, or rearranged, which is also true. So Dalton did a pretty good job for experimenting in the 1800s. All right, so now we're going to actually define what the atom is that we know of today. And the atom is the smallest particle of an element that retains the properties of the element. Okay, that's the definition of an atom. And what started happening once people took Dalton's theory and they really wanted to see if it was true or not. So they started doing experiments trying to figure out if there really was anything smaller than an atom. And the first subatomic particle that was discovered was the electron. A scientist named J.J. Thomson used what's called a cathode ray tube, which you can see right here. What he ended up doing was discovering that there are particles inside atoms called electrons that have a negative charge. So let's take a look at Thomson and his experiment. So basically, Thomson was looking at this cathode ray, which was the ray of light that we saw on the previous screen, and he noticed that it was attracted to the positive end of a magnet. And so he basically figured out that there had to be something inside an atom with a negative charge that was making up this cathode ray. Otherwise, it wouldn't be attracted to a magnet or to an electric field. So he was really the first person to identify a subatomic particle, that the atom was not the smallest thing, and there was something inside of it that he called an electron. And then Robert Millikan was able to take Thomson's idea and actually figure out that the charge of an electron is a -1 charge, and he used what's called the oil drop experiment to do that. So you can see the diagram of his experiment here in the picture. And what Millikan came up with is that the mass of an electron is based on its charge, and he figured out that an electron is almost 2,000 times smaller than the mass of a hydrogen atom. So in comparison to the other part of the atom, the electron really has very little to do with the mass. All right, so Thomson's idea of the electron leads us to a new model of the atom called the plum pudding model. And basically the idea that was upgraded from Dalton's model is that now the electron has these little things in it called, the atom has these little things in it called electrons, and the rest of the atom is just one big lump of positively charged material. So it's like raisins stuck in plum pudding. That's where it got its name from. Now, obviously, we know that that's still not true, but at the time, that's all scientists knew. They knew about electrons, but they didn't know what else was in the atom. So that's the second model of the atom after Dalton. So now scientists are trying to figure out what comes next. What else is in there? What else is going on inside the atom besides the electrons? And we get to a guy named Ernest Rutherford. And Rutherford was doing experiments with radioactive material. And he did an experiment with a sheet of gold foil, and he was basically shooting these alpha particles, which are coming from the radioactive material, at the gold foil. And what he really expected was for those alpha particles to pretty much just go straight through the atoms, maybe be deflected a little bit, as you can see here in the diagram. This is what he thought was going to happen. And then when he actually did the experiment, what he found was something completely unexpected. He found that some of the alpha particles actually bounced off the foil. Some went straight through, some were deflected at a really large angle. And so he had to change his idea about what was happening in the nucleus. In the atom, and what he came up with was the idea of the nucleus. That there had to be some small, dense part of the atom that these alpha particles were bouncing off of. That was the only way he could explain what he was seeing in his experiment, was that there was something with a lot of mass and density in the middle, and then those alpha particles were bouncing off rather than just passing straight through all of that positive mass that they thought was in there to begin with. So now scientists know, yes, there are electrons, but they also know that there's something in the middle of an atom called the nucleus that has a positive charge. All right, so we're going to take a look at a short little video about Rutherford's gold foil experiment.
The nucleus of an atom was first discovered when a beam of positively charged particles emitted from a radioactive source was aimed at a fluorescent screen. The particles caused the fluorescent screen to glow. When a very thin sheet of gold foil was placed in the pathway of the particle beam, a few particles were deflected to the side. Occasionally, particles were deflected straight back. But nearly all particles passed right through the gold foil, as if it were not there. The scientists concluded that atoms must be mostly empty space, and that because some particles are deflected, there must be a small positively charged central mass, which they called the nucleus. The nucleus of an atom was first discovered when a beam of positively charged particles emitted from a radioactive...
Okay. So all of that, all of those discoveries, all of those experiments basically lead us to what we know now, which is the complete model of the atom, where we know that the electrons are outside of the nucleus, and then inside the nucleus are the protons and the neutrons that contain most of the mass. So the atoms are spherically shaped, they're mostly empty space, and the electrons travel around the nucleus, held by an attraction to the positively charged nucleus. And we're going to get more into what those electrons are doing in the next unit. Okay, so let's kind of summarize what we know about all of our subatomic particles. So we have the electron, which is represented right here as a lowercase e with a -1 as its superscript to represent its -1 charge. It's in the space surrounding the nucleus, has a charge of -1. It is nearly 2,000 times smaller than a proton or a neutron, and its actual mass is given here. Proton, P for proton, it's in the nucleus, has a +1 charge. N for neutron in the nucleus has no charge, and protons and neutrons have about the same mass. So that's going to kind of summarize what we know about our subatomic particles. Okay.